You believe your reality is solid. You believe the past is set in stone and that your choices are your own. This is a lie. The fundamental laws of the universe, the very rules that build your world, suggest something else entirely. They suggest that you are a co-conspirator, that the universe is a story that only writes itself when you are looking, and that the most terrifying paradox of all is your own consciousness. Over the next 20 minutes, we will not just question your reality, we will dismantle it. The experiment that watches you. The world you see only exists because you see it. Turn your back, and it dissolves. It dissolves into a fog of pure potential. This isn't philosophy, this is physics. For centuries, we believed reality was a solid, dependable thing. A rock is a rock, whether you are there to see it or not. If you fire a baseball through one of two openings in a wall, it will go through either the left opening or the right opening. It leaves one mark. It is logical, predictable, real. We built our entire understanding of the universe on this simple fact. Then, we decided to try the same experiment with the smallest things in existence. We took a barrier with two tiny, parallel slits in it, and instead of a baseball, we fired a single electron. A single indivisible particle. Logic dictates that the electron must pass through one slit or the other. It should create a pattern of two simple bands on the detector screen behind it. Just like the baseballs, but it doesn't. When no one is looking, the electron does the impossible. It ceases to be a thing at all. It becomes a wave, a smear of probability. It passes through both slits at the exact same time and interferes with itself on the other side. It creates a complex pattern of many stripes, a pattern that could only be made by a wave. This result is so bizarre, so reality-shattering, that scientists refused to believe it. They decided to watch. They placed a small detector by the slits. A tiny electric eye designed to do one simple thing, to see which slit the electron actually went through, and that is when the universe played its hand. The instant the detector was turned on, the electron acted shy. The interference pattern vanished. The electron, as if it knew it was being observed, suddenly picked a side. It stopped being a wave. It behaved like a simple, solid particle again. It went through only one slit. And it produced the simple, boring two-band pattern. The act of looking forced reality to pick a story and stick to it. Why? The universe, it seems, is a shy performer, a cosmic actor that changes its entire act, the instant it knows it's being watched. But this idea, that reality waits for an observer, doesn't just apply to tiny particles. It leads to a paradox so famous, it involves a cat that is. The cat that is both alive and dead. Both alive and dead. We exist in a world of definite things. A light switch is either on or it is off. A thing is either here or it is there. It is either true or it is false. But the universe has a loophole, a place where both is the answer. In the 1930s, the physicist Erwin Schrödinger was so disturbed by this idea that he proposed a thought experiment. A thought experiment to show how absurd it was. He invented a story that has become the most famous paradox in all of science. He imagined a cat. The cat is placed inside a sealed steel box. It cannot be seen. Alongside the cat is a tiny radioactive atom and a device. A device where, if the atom decays, it will trigger a hammer. That hammer will break a vial of poison, and the cat will no longer be living. If the atom does not decay, the cat remains perfectly fine. The cat's fate is completely and totally linked to the random, quantum chance of this single atom. Now, the laws of quantum mechanics are applied. According to the rules, as long as the atom is unobserved inside the box, it is not decayed or not decayed. It is in a superposition of both states at the same time. It is a perfect 50-50 blur of potential. But if the atom is a blur, what about the cat? Because the cat's fate is tied to the atom, it also inherits this ghostly state. Inside the box, the cat is not either living or in a state of cessation. It is, impossibly, both at the exact same time. It is a wave function of a living creature and one that has perished, existing together in a single, undefined reality. The universe, it seems, refuses to make up its mind. It holds all possible outcomes in its hand. And only when we, the observers, open the box, does reality finally collapse. Only then does the universe force one of those two stories to become real. This force, this collapse, is a local event. But what if it wasn't? What if two linked objects were separated by an impossible distance? The twins who share one mind. Imagine two coins, linked by a magic thread. You flip one in London and it lands on heads. Instantly, the other coin, in Tokyo, must land on tails. This magic thread is real. It is called quantum entanglement, and it binds the entire universe together. When two twin particles are born from the same event, they share a single unified existence. They are not two separate things. They are two parts of one whole. Their properties, like their spin, will always be perfectly, precisely opposite. If one is up, the other is down. This is a known, testable fact. But this is where the magic and the terror begins. You take these two twin particles. You send particle A to one side of the galaxy. You send particle B to the other side. They are now separated by thousands of light years. Back on Earth, you decide to measure particle A. The instant you look at it, its blurry, both-ways state collapses. It chooses to be up. At that exact same fraction of a second, its twin, on the far side of the galaxy, instantly chooses to be down. The information, the choice, traveled between them. Faster than the speed of light. This is the very thing that broke Albert Einstein's brain. It violates his own sacred rule, that nothing, absolutely nothing, can travel faster than light. He called it spooky action at a distance. He was convinced it was wrong. He had to be. But he was mistaken. It has been proven time and time again. The particles are not sending signals. They are connected. It is as if they are one entity, existing in two places at once. This is the kind of reality-bending science that dismantles our world. If you, too, are a mind that refuses to look away from the paradox, then subscribe, because the rabbit hole goes much, much deeper. This isn't a theory. This is a proven mechanical fact of our reality. The universe is not a collection of separate, lonely things. It is a single, interconnected web. A web where touching one part can make the other side tremble, instantly. This spooky action breaks the laws of space. But what happens when we apply the same quantum logic to time? The choice that remade the past. You cannot change the past. It is fixed, solid, done. The choices you made yesterday, the words you said, the paths you took, they are all set in stone. The universe, it seems, disagrees, and it has receipts. We must return to the double-slit experiment. The rules are simple. If you don't watch, the electron is a wave. If you do watch, the electron is a particle. The act of looking is what makes it choose a single path. But what if we tried to trick it? What if we let the electron make its journey first, and then decided whether to look at it? This was the genius of the physicist John Wheeler. His delayed choice experiment is a cosmic trap. We set up the experiment as normal. We fire the electron. It passes the two slits. At this point, it is already on its way to the detector screen. In its wave state, it has already gone through both slits at once. After it has cleared the slits, but before it hits the final screen, we make a last-second choice. We either do nothing and let it complete its journey as a wave, or we instantly slide a special detector into place to catch it and see which path it took. The electron is already past the point of no return. Its past, its history of being a wave, should be set. But the universe is a far stranger place. When the experiment was finally performed, the results were chilling. If the scientists chose to not look, the electron hit the screen as a wave, creating the interference pattern. But if they made the last-second choice to look, the electron's behavior changed. Retroactively, the wave pattern vanished. It was as if our choice in the present reached back in time and edited the past. It forced the electron to go back and choose a single slit. The past, it seems, is not as solid as we think. It may just be another fog of potential, waiting for the present to give it a definite shape. If our observation can edit the past, what can it do to the future? Can it stop it completely? The watched pot that never boils. You've heard the saying, a watched pot never boils. It's a quaint metaphor for impatience. But what if it wasn't a metaphor? What if you could stare at an atom and freeze it in time? This is the quantum Zeno effect. It is one of the strangest, most powerful consequences of the measurement problem. We begin with an unstable particle. A radioactive atom. It is programmed by the laws of physics to decay. It has a half-life. In a few moments, a few seconds, it will pop. It will transform into a different, more stable particle. Its future is set. But scientists decided to interfere. They decided to watch the atom. They didn't just glance. They set up a system to measure it, relentlessly, thousands of times per second. The experiment became a constant, rapid-fire question. Are you still there? Are you still there? Are you still there? Every time the system measured the atom, it found it in its original, undecayed state. And every measurement resets the atom's internal clock. It forces the atom, by the laws of observation, to collapse back into its starting position. The result? The atom never decayed. The relentless, obsessive act of looking trapped the atom in a perfect frozen loop. It was paralyzed, prevented from moving forward in time, prevented from having a future. This has been experimentally confirmed. You can freeze reality with a look. The universe, it seems, is a shy performer. The spotlight of our observation doesn't just record the show. It dictates the script and can even freeze the actors in place. So, observation can rewrite the past and freeze the future. But what about the laws of the present? What about a wall? The ghost in the wall. There is a wall in front of you. It is made of solid concrete. You cannot walk through it. Your particles, and the particles of the wall, will not allow it. Except, sometimes, they do. In our world, the world of classical physics, the rules are absolute. If you roll a ball at a hill, and that ball does not have enough energy to reach the top, it cannot get to the other side. It will always roll back down. The hill is, for that ball, an absolute barrier. Our universe, thankfully, has this rule. It's what keeps your feet on the floor and your chair from sinking into the ground. But in the quantum realm, the rules are more like guidelines. This is quantum tunneling. A quantum particle, like an electron, can appear on the other side of a barrier it does not have the energy to cross. It is not a matter of if, it is a matter of when. The particle approaches the impossible wall. Its wave function, its cloud of probability, smears out. A tiny, tiny fraction of that wave leaks through the solid barrier. And there is a small, but very real, statistical chance that the particle will tunnel and simply reappear on the other side, having never had the energy to climb the wall at all. It doesn't break the wall. It borrows energy from the universe for an impossibly short time, pays it back, and appears on the other side. This isn't a rare party trick. It's the reason the sun shines. The fusion in the sun's core, the very engine of life, only works because protons tunnel through the barrier that should, by all classical laws, keep them apart. This is the ghost that powers our entire modern world. It's a conspiracy hidden in plain sight. What other paradoxes make you question the walls of your own reality? Leave your thoughts in the comments below, and see what other observers have found. The laws of physics are not a fortress. They are a game of probabilities, and the universe, it seems, is a high-stakes gambler that loves to bet on the impossible. But this gamble, this game of chance, has a dark implication. What happens to the realities that lose the bet? The you who didn't turn left. Every choice you make, every path you don't take, splits the universe in two. There is another you, and another. An infinite ocean of yous who made the other choice. This is the many worlds interpretation. It is the most elegant and most terrifying solution to the paradox of Schrödinger's cat. Let's revisit the box. The problem has always been this. When we open the box, why do we see a living cat? Why does the universe pick our reality to be the one where the atom didn't decay? What happens to the other possibility, the one where the cat perishes? The many worlds theory provides a simple, horrifying answer. It doesn't pick. When you open the box, reality fractures. It cleaves in two. In one universe, in one branch of reality, you open the box and see a living cat. You are relieved, and you go on with your day. But in another, identical universe, another version of you opens the box at the exact same moment and finds a cat that is no longer living. Both outcomes happen. Both are equally real. This isn't just about cats in boxes. This happens for every quantum event. Every single time an electron chooses to be up instead of down, the universe splits. This means there is a version of you who took that job. A version of you who missed that train. A version of you who never met that person. A version of you who said yes when you said no. Every quantum coin flip, every both ways possibility, splinters off into its own parallel, tangible reality. The ghost of the life you almost had is very real. It's just living next door, in a dimension you can never, ever see. This theory is profound. But what happens when you combine it with the one thing you can never observe? Your own cessation. The God in the box. This is the most terrifying thought experiment in history. Take the many worlds theory, the one that says all outcomes happen. Now, put yourself inside Schrödinger's box. This is the idea of quantum immortality. It is a dark, logical conclusion that twists the paradox into a personal horror story. You build a quantum gun and point it at your own head. This isn't a normal gun. It's a mechanism linked to a quantum trigger. It measures the spin of a particle. If the particle is spin up, the mechanism does nothing. You hear a click. If the particle is spin down, the mechanism releases a substance that causes the immediate cessation of life. It is a perfect 50-50 coin flip. You pull the trigger. The universe splits. In one timeline, click. The particle is spin down. The fatal outcome occurs. Your story, your consciousness, your experience of the world ends. But in the other timeline, click. The particle is spin up. The mechanism fails. You are perfectly fine. You are alive. And here is the cosmic punchline. You, your consciousness, can only experience the timeline where you survive. You cannot, by definition, experience the timeline where you cease to be. So, from your perspective, you pull the trigger. Click. You're fine. You pull it again. Click. You're fine again. You pull it 1,000 times. 1,000,000 times. The gun always misfires. The particle always spins up. You will watch the mechanism fail, over and over, in a streak of luck that defies all statistical probability. From your point of view, you cannot perish. You have become a god, trapped in a single, miraculous timeline, watching everyone else around you grow old and succumb to time. This is a story that feels like it belongs in a dark novel, but it's born directly from the mathematics. This is an idea that must be shared. Send this to someone whose reality you want to break. This is a cosmic punchline of the darkest order. You are, from your own point of view, immortal. And there is no way to ever prove it, or to escape it. But this entire idea hinges on your observation. What if your observation is just someone else's experiment? The friend who doesn't exist, Schrödinger's cat, was a simple problem. A cat in a box, an observer. But what happens if the observer is also in a box? Whose reality is the real one? This is the Wigner's friend paradox, and it is a puzzle that tears at the very definition of reality. It is a set of nested boxes. Here is the setup. A scientist, we'll call him the friend, is in a sealed laboratory. He cannot be observed from the outside. Inside that sealed lab, the friend performs the Schrödinger's cat experiment. From the friend's perspective, the experiment has a definite outcome. He opens the box. He sees a living cat. For him, the wave function has collapsed. The cat is real. His reality is set. But now, we zoom out. We are now Wigner, the second scientist, standing outside the sealed laboratory. From Wigner's perspective, the entire lab is now the experiment. The friend and the cat are both part of one giant quantum system. Because Wigner has not looked inside the lab, the friend is now in a superposition. The friend is in a state of seeing a living cat and seeing a non-living cat at the same time. The friend's entire reality is a blur. Until Wigner opens the lab door and asks him, "What did you see?" This is the core of the problem. Whose look is the one that counts? Does the friend's consciousness collapse the cat, or does Wigner's consciousness collapse the friend? And if Wigner's look collapses the friend, who looks at Wigner to collapse his reality? Reality is a set of nested boxes. And it begs the question, is it possible that we are all just in a superposition, waiting for some cosmic Wigner to open the door and ask us what we saw? This question, this single unanswerable problem, is the foundation of everything. The conspiracy at the heart of reality, we've seen it over and over. Looking changes the world. Observation freezes time. A choice remakes the past. But what is an observation? This is the measurement problem. It is the central mystery. It is the one terrifying thread that connects all of these paradoxes. It is the biggest, darkest secret in all of physics, the one that nobody can solve. What does it take to collapse the fog of potential into one solid thing? Does it have to be a human eye? Does a camera count? If a tree falls in the forest and a squirrel sees it, is that real? What about a dust mote simply bumping into the electron? Does the dust mote know? Does the universe require a conscious mind to be looking at it in order to become solid? This is the forbidden line where physics becomes something else. For decades, the official answer from physicists was, shut up and calculate. The math worked, so the why didn't matter. But the why is the only thing that matters. Is reality a collaborative performance between us and the universe? Is it a story that waits for a reader before it writes itself? Or is consciousness just a cosmic accident, and measurement is just any simple, physical interaction? No one knows. This is the biggest secret in all of physics. The universe, it seems, has built a reality based on a rule that it refuses to define. The punchline is that we live inside a story that only seems to write itself when we are reading it. We are the ghosts in the machine. We are the audience that makes the play real. The conspiracy at the heart of reality is us. And that is the most terrifying and most profound paradox of all. The story is not done. If you too are an observer who refuses to be unwatched, subscribe and join the paradox.